Hello everyone, and welcome back to another remote sensing lecture video. And in this lecture video, I want to pick up where we left off talking about this classification and change detection. And in specific, what happens when we run this multitemporal image. So again, that's two time periods stacked together in one image. What happens when we run this into a classification algorithm? And so we left off last time talking about what would happen to each one of these time periods separately. But now let's talk about what would happen when we put them together like we have and we run them through a classification algorithm. So again, the nice thing with classification algorithm is it takes these 6 bands and our output is just that one band, right, where the pixels are now classified into classes. And let's think about what would happen here. So our pixel 1 was vegetation in time 1, right? That's what these pixel values here represent. But it was burned to the ground and is now bare earth in time 2. This pixel here was vegetation at time 1, but it was also vegetation at time 2. Right, this pixel here was urban at time 1 and urban at time 2. And this pixel here was soil at time 1, but it had been converted to vegetation at time 2. So if you remember back to this idea of map-to-map comparison, when we had a classification for time 1 and a classification for time 2, right, we were like, oh, it was urban in this case, it was vegetation in this case, we made a map class. Well, we're going to be doing something similar here, but we're actually going to be doing the classification directly from the raw reflectance values, right? So what would happen most likely is a classifier would see these pixels here and say, that's one class. We'll make it, say, purple for class 1. Okay. It's then going to look at this pixel here and say, well, it's not class 1, right? Because these pixel values stayed the same, right? So it's a different class. It's class 2. It's going to look at this pixel and say, well, the pixel values stayed the same relative between time 1 and time 2, but they're different, right? These pixel values are different than these pixel values. So it's not the same as class 2. It's a different class, so we'll call that class 3. All right, and then it's going to look at let's do red. Then it's going to look at this pixel here, and it's going to say, well, this pixel value, this is a different class yet again. It's going to call this class 4. Right, so then this would be unsupervised classification, right? We would have to then figure out what these different classes mean, right, by looking at the imagery and doing all those sort of elements of interpretation that we did for unsupervised classification. Right, if this was supervised classification, you would manually label these pixels. Right, you might manually label this pixel as burnt earth or forest to burn ground. You might label this pixel as forest. You might label this pixel as urban. And you might label this pixel as soil to forest. Right? You would pre-label the classes. But the point here is again, right, we're running the classification algorithm. We're not doing a map-to-map comparison. We're actually running the classification algorithm, and the classification algorithm is finding the differences between these pixels to assign them to classes. So again, I know this is a very small example here. You would have an image again, with tens of thousands of pixels. But the idea here, the thing that I want you to walk away from, is that with the classification and change detection, right, we have two time periods smashed together in a single image. And the classification algorithm is looking at not only time 1, but also time 2, and how the pixel values between the two time periods change, right? Because this pixel here has a very different spectral profile, right? Again, that's the pixel values, not the spectral response curve, right? The pixel values are very different because time 2 is very different between this pixel, which is vegetation here, and this pixel, which is vegetation here. So hopefully this makes sense. I know it's a lot. Take your time with it. Go back, rewatch this video, rewatch the previous video. Make sure that you understand conceptually what's happening when we have time 1 and time 2 in the same image and we run the classification on it. Why we got these 4 classes. Why each one of these are different. Right? Why this vegetation that is not changing is different from this urban that's not changing. Why this vegetation that is changing is different from this vegetation that's changing, is different from this that changed to vegetation. Right? So hopefully that makes sense. And as always, please reach out. Thank you.